Today we're going to go over the command pattern. The command pattern is designed on encapsulating operations as objects. If we encapsulate these operations as objects, this will make it more easily able to undo operations as needed. We can easily create a more easier way of keeping a history of these operations, as well as we can queue operations as needed within our application. Thinking about maybe a form or a database editor or some tool where users need to undo their last action. This is a nice and easy way of understanding why we might use the command pattern. We have a problem, so let's think about building a simple database manager. Our users will fill in a form, and through this form, they'll be able to insert records into our database. They might need to undo those inserts. If there's no structure, then we might just simply store the last inserted record into a variable. When we need to undo that insert, we might just delete that variable. But what if we want to undo multiple steps instead of the last step? What if we also want to undo those delete operations? So what if we also want to have an operation log? When we have a lot of these new requirements, we're kind of thinking more and more about adding more state into the component, and also thinking about how there can be reversal logic alongside with the insertion logic, so there's no clean seam between what triggered the action and what the action actually does. In the pattern overview, the gang of four describes this as a behavioral design pattern. The definition is encapsulate a request as an object, thereby letting you parameterize clients with different requests, queue or log requests, and support undoable operations. The one-line version, instead of calling a method directly, we wrap that call in an object. That object knows how to do a specific thing and how to undo it. It only knows how to do those both things. We hand it to an orchestrator called an invoker, and the invoker executes it. And it keeps a history stack, so the undo becomes a simple pop and a method call. And so we're going to look at the participants, the command, concrete command, receiver, invoker, and client. Here's the structure diagram. This is the structure diagram before we go into the code. There are four key roles. There's the command interface. This defines the two method contract, the execute and undo. The concrete commands themselves, they implement that contract, each wrapping a specific operation against a specific receiver. The receiver is the class that actually performs the work. The invoker is the orchestrator. It holds the history stack and knows when to execute and when to undo, but has zero knowledge of what any operation does. Hereby we can create more abstraction, and we eliminate a lot of the coupling through this structure. The first one we'll talk about is the command and database, the participants here. So in this specific repo, we have first the command interface. This is the backbone of the whole operation. It declares exactly two methods, the execute and also the undo. The execute will return something, and the undo will return something as well. That's the entire contract. Any operation that wants to participate in the undo mechanism must implement both. The database interface in this repo is the receiver contract. It declares the insert and delete. The concrete commands will be programmed against this interface, not the concrete class, which keeps them decoupled from all the DOM manipulation details that we have within this repo. that we call from the form. And the data type is just a very, very basic plain record, which just includes the ID, username, and information stored for each command for reversal. Commands store this value in the constructor, so they have everything they need to reverse themselves later. The application database is the receiver. This is the class that does the actual work. Its constructor takes in the in-memory data array and references to 3 DOM elements. There is a username list, the information list, and the action log. When you call insert, it pushes the records into the array and appends list items to all of the 3 DOM columns. When you call delete, it filters the record out of the array by ID and removes the last list item from each column. The receiver doesn't know anything about the commands, history, or undo. It just knows how to insert and delete. That's the clean separation the pattern will buy you. The participants here, the insert database and delete database, these are the concrete commands where the undo magic actually lives. So the insert database takes a receiver reference and the data record in its constructor. Execute calls the database insert, and undo calls the database delete. For the data. The inverse operation already knows this at construction time. The delete database is the mirror image, it's the reverse. So the execute will call the delete from the database, and the undo call will perform the insert. This is the key insight. Each command object only captures the state it needs to reverse itself. You don't look up anything later. The data is already in the object. So last we have the database application. So the database application is the invoker. It maintains the command list. So the command array, it's a simple array used as a stack. When you call insert on the invoker, it creates a new insert database. It's a new insert database command. It pushes it onto the stack and calls execute at the same time. When you call undo, it pops the last command from the stack and then calls its undo method. This is literally the entire mechanism. The invoker never imports the library or the DOM library. It never knows what the data record looks like. It just only manages the command objects. The separation of concern is in all of this. Finally, we're going to look at this command interface. And so here is just the full command interface. It's very simple. It just has the 2 methods, nothing else. So the execute performs the operation, the undo reverses that. Now we have the database receiver interface, which only has the insert and delete typed against this shared data record. These 2 interfaces define the entire protocol. Any new operation you want to add to the system is a new class that implements command and calls the methods on the database. So for this code, here's the insert database in full. The constructor captures the database, that's the receiver, and data, the record. Execute delegates to the database insert. Undo delegates to the database delete. 4 lines of real logic, it's maximum clarity. The symmetry between the 2 methods is the whole point. Execute does the thing. Undo reverses it by delegating the opposite operation. Here's where the invoker key methods wire everything together and how the index Typescript file works. It hooks them up to the DOM. In the insert, the invoker creates the command. It creates the command, it pushes it, and executes. In the undo, it pops from the array list and it calls the command undo. The form submit handler in the Typescript file calls the database app insert data, and the undo button calls the database app undo. The client has no undo logic of its own. It's entirely delegated to the invoker and its command history. Here, this is my demo app on my GitHub page with the information, some demo that we're going to kind of go through from here. In the top part, we have this flow of the invoker creating the command, which will apply an action to the receiver. We're going to just have this fake database here on the left side. We have an undo button, and we have some logic to insert a record. So from here, we'll insert a record here. So we have the history. We have these inserted into our database. If we undo or remove, we remove the last one, which was 3. If we put it back in, we have a completely, we have another insert that's recorded here. So from here, we're going to look a little bit more carefully, closer into the code here. All of the logic is being performed on this submit button here. We're looking at the database application, the invoker here. So the invoker is the one that's going to be calling these specific methods of insert and undo. But from here, inside of this logic, since we have clicked the insert, from here we're going to have in the database application a command array that every time we do an insert, we're going to create that action, the database action of inserting into the database or deleting into the database, depending on what is being called here. And from here, we're going to push that into our command list, and then we're going to execute that command. For the insert database, that means that we have the application database. That's the one that's receiving the action. And so when we execute it, we insert. The insert is applying onto the database application. That means that here we're going to have a lot more of the logic that's going to actually perform actions or the mutation and the DOM updates for our application. So it's going to have, we're going to push data, we're going to add the username, add the info, add the logic. And if we're going backwards here, if we go all the way back here, if we undo it, so we're calling the same database application to undo. From here, we go back to this command list here. We pop the last one that came. So that was the most recent one that came here. We pop it. Then we also perform this undo action. The undo is actually depending on what action got inserted, whether it was an insert or delete. If it was the insert, if we undo it, we will perform this database delete, which is from the application database. From here, we'll perform the same type of action or mutation here, where we'll delete the info, delete the username, delete the log, but all of the complex logic is separated here from the command. We're not putting any deep logic in there. We're calling onto this application database to perform these different actions here. So if we undo these last ones, then we can remove the information, but if we had a delete on the record, we could redo it here. This is more of again, an overview of the demo that we just did. So if we're looking at this flow, inserting a record, once we typed in the name, also some record into the form when we insert it. So we have the form handler, it increments an ID, it builds the data, it calls the database app insert. The invoker creates a data insert database command. So it pushes that onto the command list, then it will call execute. That's when on the execute, the application database will insert. That means it updates the DOM. Alice appears in both of the columns. So then we have all this information both in the columns, both columns and in the history logs. If we had the undo button, so once that is clicked, the database app will do an undo. That means the command list is popped. We get the last command, which is the insert database. So then on that command, we do an undo. In the insert database command, that will mean that that's the database delete. So then it filters all the records, it removes that row. If we delete again, the command will be popped, so then another row will be removed since it's an insert database command. If it's empty, if we do an undo, since we have some undefined safety here, an empty stack with no undo, it won't have any issue and there'll be no crash. If we look at when we would use this, the command pattern. So if we ever have to do undo or redo support, that would be maybe with audit trails or operation history, queuing or replaying operations. If we have job queues or macro recording. Also, anytime that you want to have a clean architectural seam between the code that triggers an action and the code that executes it. If those two things are drifting towards each other in your code base, then the command pattern is the right tool. For when we would not use the command pattern, so here we think about when operations are simple in one way, so we don't really need to do an undo, we don't need to keep a history, there's no queuing that's needed. We only have one command type, so we're only doing one action or one operation. So having one interface for one specific class is a bit unnecessary, it's over-engineering. We don't need to have that kind of complicated abstraction. High frequency operations where per call object allocation is a performance concern. If we're doing a lot of operations at one time, if we're doing parallel operations, this might not be the best case to do the command pattern. It'd be something to kind of consider and think about. And the operation has no meaningful inverse. So if we're thinking about sending an email, we don't really have a undo or reverse operation of sending that email. Maybe you're writing to an append only log. So if we're writing to the append only log and we're keeping a track of the log, we wouldn't in any case want to undo that action or reverse it. We would always want to keep more information on that log. If we think about a real world analogy to help understand the command pattern, the first one is we think about a restaurant order ticket. So you don't walk into the kitchen and tell what the chef to make. You tell a waiter who writes a ticket. The ticket is the command. It encapsulates what to prepare for and for whom it's supposed to be prepared for. And the kitchen is the receiver. The manager can come by and cancel a ticket, push it to the back of the queue, or replay it. So those are the undo and queuing built into the workflow. The second one to think about is a text editor. We always have the Control-Z undoing action. Every key press, paste, and format change in the professional editor is wrapped into a command object. If we think about the Control-Z, it pops the history stack, it calls the undo on the top command. Control-Y just re-executes it. So there's no last action Boolean in sight. The third one is thinking about a TV remote. Each button is a command, the remote is the invoker, the TV is the receiver. So we swap the TV for a projector, and the remote still works in the same way, because the invoker and receiver are decoupled. Comparing it to other related patterns, so there's two different patterns that come up when we discuss the command pattern. The first one is the strategy pattern. It looks very similar because they both swap out behavior, but the intent is very different. Strategy is about choosing how to do something, which algorithm, which payment processor. It's stateless between calls. Command is about capturing that something was done, so it has a history and an undo mechanism baked in. The chain of responsibility also routes requests, but differently. The chain of responsibility passes a request along a chain until some handler accepts it. So it's like middleware or forum validators. Command just hands a single encapsulated request from the invoker directly to receiver. The request doesn't travel, it just executes. In summary, there are 3 takeaways to close. So the first one is commands are objects, not calls. Wrapping operations in objects give you a history, allows you undo, and queuing with no additional framework. The second one is the invoker and receiver are completely decoupled. Neither imports the other's logic, so you can swap one without touching the other. And 3, the undo is designed in, not bolted on, because each command stores the data it needs to reverse itself at construction time. So the undo is just a pop and a method call. So thanks for watching. The full source code is in the repo that's in the description. If this worked for you, if this clicked for you, then the next video I'm going to make is on the memento pattern. It's another approach to undo, but it works very differently by snapshotting the full state rather than inverting the operations. It's got very different trade-offs, but it's worth comparing these two. And subscribe and hit the bell if you don't want to miss any other part of the series. I'm working through all the different design patterns and typescripts one at a time. So thanks for watching.